Hello, today I'm going to go through with you some statistical analysis questions. First up is scatter diagram and linear regression. As you can see from this question, we are presented a table with 8 pair of data points from 8 students. It says write down the product moment correlation coefficient, write down the equation of the regression line. So these two, when they say write down means you only need to write down. So you don't need to show any working out at all. As you can see, the marks allocated would be just like this. 1 mark for R, 1 mark for your mx plus c, written down correctly. And then it says a 9th candidate obtained a score of 7, blah, blah, blah. And so you need to use your answer to B. To answer further. So say if you have done B wrong, but you used it to answer this part C correctly, then you will get the marks. Part D, give a reason why it is valid to use the regression line, blah, blah, blah. So that's 6 marks. So this is one of the questions that you can find in the short answer paper. So to quickly do what we need to be doing, we have to have a spreadsheet with X here for your physics and then Y for your chemistry. Enter and then you have 8 like that. So you have your 2 columns of data. Now this is by variate, so 2 variables. So make sure if you do anything, you need to be stating that you are doing a 2 variable stats. But here, in order to carry out the linear regression, we need to go to menu, statistics, and at this time is stat test. You need to go down to this, your A, linear regression, t-test. The X is in our X column, Y is in the Y column. That's when you're labeling the columns are so handy. Save the regression equation to function 1. You can ignore that. You don't need to be worrying about the alternate hypothesis. I don't think your calculator has this function as well, so this is my CX type 2. Store the result column in column C. Okay. So this is what we got. This is a linear regression. The regression equation is written in this form, so take care of writing it down. You need to scroll down for your R. So this is your R. So now you have what you need. Part A, R is equal to 0.96511 blah blah blah. Now you can write it out in like this if you don't want to do the rounding. But if you have to do the rounding, it should be like this. If you don't do rounding, make sure you are doing 3 significant figures or better. But without stating the level of accuracy in your rounding, we always just do 3 significant figures. Part B, again, we can write down, just scroll back up to find our linear regression line. It says A plus bx. So y is equal to A plus bx. So you can do, what is your A? This one, 0.97560 plus your B is 1.15447 x. To write it more properly, you should write them in three significant figures. So if you write it in y equals to mx plus c form, you can rearrange it. So it becomes 1.15x plus 0.976 for your C. Part C, it says use your answer in B to estimate the score you would have obtained in the chemistry test. So in the chemistry test is what we do not know. So we want the score of the chemistry test. We are given the score of physics. So physics is our x. So we substitute x in. Now you have two options here. You can just directly do y equals to times the 7. Then evaluate it out. Or you have the option of going to the calculator, because it's stored in your F1. Stored in your F1. So you can just put 7 and enter. This would give you 9.06. This is the score for the chemistry test. Now, whether or not you need to round it up to the whole number, I don't think it is necessary. You can leave it as such, or you can just say about 9. But we must see this, so don't just go directly to 9. Let's double check. If we enter 1.15 times 7 plus 0.976. And there you got 0.93. The reason is because we chuck off quite a bit of decimals, and the error will build up here at the third and the fourth decimal places. Part D, give a reason why it is valid to use this regression line to estimate the score. Because 7 is within the range of data given, and what else? What else can you say? You can also say because R is strong, positive. The correlation coefficient is so close to 1. The relationship between the two variables is very strong. Therefore, you can definitely use the line to estimate the score. Next one is like this. So Alex and Chris are riding the bicycle together along a bicycle trail and note the following distance markers at the given times. So times are in hours, distance are in kilometers. Draw a scatter diagram. This one is a long question. So you need to draw a scatter diagram. Pay attention to the instruction. It says, use 1 centimeter to represent 1 hour and 1 centimeter to represent 10 kilometers. These, following this instruction, will give you marks. Okay, so make sure you follow these. Next, it says write down for this data. Write down. This is a clue for you to use the GDC. It's only 2 marks, so you really should not spend the time key separate numbers into the calculator to work it out. And then it says mark and label the point T and D, mean of T and mean of D on your scatter diagram. Draw a line of best fit. And then using your graph, estimate the time. So you must use your graph, even if it is wrong. Then you use yours, it's fine. And then it says give your answer to 1 decimal place. When they say that, meaning 1 mark is dedicated to this rounding process. Next, write down the equation. Write down, again, straightforward from the GDC. Then, using your equation, calculated the distance marker. So using your equation, again. Whatever that you have written in F, you must use in G. Is this estimate reliable? So pretty much same as before. Now, I don't have graph paper. I'm not going to draw this. What I'm going to do is to close this document, and I'm not going to save it. Again, go back to the spreadsheet, put T for hours, D for distance. Enter your data in. I am going to ask the calculator to draw it for me. Chart. Put T across because it's the independent, and the distance is the dependent one. So you can see the lines pretty much follow a straight line. So this is a linear relationship between the two variables. For you, on paper, you need to pay attention to that you have your distance here and your time here. Starting from 0, you need to have in hours. This is in kilometers. And with the scale, 1, 2, 3. Da, da, da. And then over here, you will have your, say, every 20. Oh no, what did it say? 1 centimeter for 10. So you do need to have like this going up. Just by drawing this and putting the labels on will give you 1 mark out of the 3. Okay, we have this graph on here. What I need to do is to answer these questions. I better go back to my spreadsheet because I only need to write down. I'm going to ask it to do statistics. This time, I'm doing stat calculation with 2 variables, like that. Okay, I got these to look at. The mean of x. Now our x is our time, so 4. B1, 4. Or you can write mean of t is 4. Part 2, mean of d, go down, 81.1 1 kilometers. C, mark and label it. So you need to have a 4 about here, 81 something about higher up there. So you need to mark it, label it, M. Mark and label. So you do that. Draw a line of best fit. Now your line of best fit must go through M, and it doesn't need to be at 0, 0. You just need to make sure that it's passing through a good enough points. Give a good balance top and bottom. And then you should have, making sure it's passed through M. Then it would be very good. Then it says, use your graph to estimate the time when Alex and Chris pass 85 kilometers of the distance marker and round it to 1 dp. Here, make sure you don't use your calculator to do it. So you don't go about and say, oh, F1, and then enter 85 there. You must use your graph. So you must start from saying somewhere at 85 across to the line and down and find out the time like this. And then round it to 1 dp. F, it says write down the equation of the regression line given. If you only have done the 2 variable stats, you won't see those things for your regression line. You will see though the correlation coefficient. So here you need to go back to menu statistics. Now I know in the previous question I asked you to use statistic and stat test and go to linear regression t-test. But actually the faster way should be statistics, stat calculation, and go here, linear regression mx plus b. T, D, save the equation in F1, and then now column E, far, far away from here. You need to go up, mx plus b, m is 8.25. So your part F should be written as y, no, sorry, not y, because it's supposed to be according to D and T. So make sure you use that. D is equal to 8.25 T plus 48.1. There, 48.1. Then says use your equation to calculate the distance. Now this time, you can go to your calculator, key in F1, and put in the hours, 10.3. Enter. So G1, your answer is 133.117. So 3 significant figures should be this, 133 kilometers. Part 2, is this estimate of the distance reliable, and give your reason why? Well, here you need to have, if you analyze the marks, 4 marks, roughly you can give 2 marks for this one and 2 marks for this one. In that case, you need to have 2 reasons here. First one, 10.3 hours. Is it reliable? Well, 10.3 hours is outside the range of data given, right? However, what do you notice about R? When you are calculating and looking at the values, I do notice it's quite strong, isn't it? The R is 0.999, is almost 1. Almost a perfect linear relationship. So if that's the case, you can also argue it is pretty reliable.